Welcome to the DIY Honda Garage channel. The DTC P1129 relates to a map sensor issue in the Honda Accord from the years 2008 to 2012. The map sensor, or manifold absolute pressure sensor, measures the pressure in the intake manifold to help the engine's computer determine the appropriate amount of fuel to inject. When the signal from the map sensor indicates a value that is higher than expected, the computer will trigger this diagnostic trouble code. This can affect engine performance, leading to symptoms like poor fuel efficiency or rough idling. It is crucial to resolve this issue as it can impact the vehicle's overall performance and emissions levels. This presentation will walk through the steps for diagnosing and troubleshooting DTC P1129 effectively to ensure optimal vehicle operation. DTC P1129 pertains to a situation where the map sensor signal is higher than expected for prolonged periods. The map sensor plays a vital role in regulating engine performance by measuring the airflow and calculating the atmospheric pressure to determine the optimal air-fuel mixture for combustion. Its position is typically situated near the intake manifold, making it crucial for its function. When voltage readings exceed 1.14 volts or the pressure exceeds 36.9 kilopascal, 11.0 inch per minute, 277 millimeters inches for more than 5 seconds, the onboard computer registers this anomaly. This can lead to underlying issues, including environmental concerns due to elevated emissions and potential performance reductions. Addressing this error swiftly will improve overall vehicle reliability. Several potential causes contribute to the DTC P1129 diagnosis. The most prevalent is vacuum leaks, which may occur in components like the PCV valve, throttle body, or intake manifold. Such leaks can lead to incorrect pressure readings at the map sensor, prompting the error code. Another likely culprit is a faulty map sensor itself, which may not provide accurate data due to wear or damage. Additionally, electrical issues, including poor connections or damaged wires between the map sensor and the engine control module (ECM), can also generate this trouble code. Identifying these causes during the troubleshooting phase is essential for effective repair. Each possibility requires different approaches for verification and resolution. Common symptoms of the DTC P1129 are noticeable and affect the driving experience significantly. Drivers may first notice poor acceleration, making the vehicle feel sluggish. This can be very frustrating, especially when attempting to merge into traffic. High fuel consumption is another significant symptom, as a faulty map sensor can cause an imbalance in the air-fuel mixture, leading to inefficient combustion and elevated emissions. Additionally, a rough engine idle may occur when the vehicle is at a standstill, indicating that the engine is not operating smoothly. These symptoms can compound, leading to further mechanical issues if not addressed. By monitoring these signs, drivers can take timely action to prevent extended damage to the vehicle. The first step in troubleshooting DTC P1129 is to inspect for vacuum leaks. This process involves carefully examining several key components, including the PCV valve, PCV hose, evap canister purge valve, throttle body, intake manifold, brake booster, and the brake booster hose. Vacuum leaks can significantly affect the map sensor's readings by altering the pressure detected in the intake manifold. If leaks are identified, it is necessary to repair or replace the respective parts. Once repairs are completed, it is important to proceed to Step 9 to ensure proper diagnostics. If no leaks are detected, then the technician should move on to the next step in the process, as it indicates that the issue may lie elsewhere in the system. In Step 2, the process involves starting the engine and holding the engine speed at 3,000 RPM. This should be done without any load on the engine, ensuring that the automatic transmission is in park or neutral, or the manual transmission is in neutral as well. Maintaining this RPM is crucial until the radiator fan engages, at which point the engine can be allowed to idle. This step helps simulate conditions under which the map sensor operates and can provide insights into its functionality. If the map sensor operates correctly at this speed, it suggests that the issue may be related to the idle conditions or other operational parameters. Following these instructions sets the stage for further testing and observations. During troubleshooting step 3, it's essential to check the map sensor while monitoring the data list using the HDS or Honda Diagnostics system. Specifically, you want to see if the pressure exceeds 36.9 kPa, that's 11.0 inches of mercury, or 277 millimeters of mercury, or if the voltage remains above 1.14 volts for more than 5 seconds. These parameters are critical in determining the sensor's accuracy during normal operation. If the readings indicate that the value is too high, this confirms that the map sensor is reporting inappropriate data to the vehicle's computer. If this situation occurs, the technician should proceed to step 7 for further diagnosis and repair. Recording the map sensor data can help identify underlying trends that may lead to additional diagnostics and solutions. In troubleshooting step 4, the next action involves clearing DTC P1129 using the Honda Diagnostics system. This step helps reset the error codes and allows the technician to establish a fresh diagnostic environment. After clearing the code, the technician should conduct additional checks for any persisting issues. It's essential to monitor whether the same code reappears, as persistent codes indicate ongoing problems that require further investigation. This step is vital in preparing for the next phases of the diagnostic process. Clearing DTCs can uncover intermittent issues, enabling better visibility into the vehicle's operations. If the DTC does reappear, further analysis of the previous steps will likely be necessary. Moving to troubleshooting step 5, the technician should perform a test drive under specific conditions to evaluate the vehicle's response. The criteria for this test include ensuring that the engine coolant temperature, as indicated by the ECT sensor, exceeds 158 degrees Fahrenheit, 70 degrees Celsius, and that the engine speed remains between 1400 and 5500 RPM. The vehicle should be operated in drive for automatic transmission or in 5th gear for manual transmission at a consistent speed of 55 to 75 miles per hour, 88 to 120 kilometers per hour for at least 10 seconds. Following this period, the technician should decelerate with full closure of the throttle for 5 seconds to monitor any changes in engine performance. This step is pivotal in assessing the system's operation under standard driving conditions, revealing potential faults with the map sensor or any related components. In step 6 of troubleshooting for DTC P1129, the next step is to monitor the OBD, onboard diagnostics status, through the HDS interface. The technician needs to check if the diagnostic system indicates a failed status for DTC P1129 after conducting the test drive. If the HDS indicates that the status is failed, this necessitates further investigation as the issue persists. Conversely, if the system indicates a passed status or an intermittent failure, it may suggest that the current system is operating correctly at that moment. Technicians should then examine for poor connections or loose terminals connecting the map sensor to the ECM, engine control module, or PCM, powertrain control module. If the HDS shows a not completed status, redoing the previous test drive is advisable to ensure accurate data collection for further evaluations. Troubleshooting Step 7 requires turning the ignition switch to the lock position, denoted as position 0. This step is crucial before proceeding to replacement of the map sensor to ensure safety and prevent any electrical mishaps. Once the ignition has been turned off, the technician can prepare for the replacement of the map sensor. It is important to note that handling electrical components requires precaution to avoid damage or static discharge. After taking necessary precautions and ensuring other systems are also turned off, the actual replacement process can be conducted carefully. Once this step is completed, the technician should move forward to the ignition switch to on, transitioning to the next phase of the repair process. For troubleshooting Step 8, the focal point is replacing the map sensor. This part is critical in ensuring comprehensive engine performance by accurately relaying pressure information to the ECM. When replacing the sensor, technicians should ensure that they use high-quality, OEM, original equipment manufacturer components to prevent future issues. The installation should be performed meticulously, ensuring all connections are tight and that there are no obstructions. Failure to properly install the sensor could lead to ongoing inaccuracies in the readings, resulting again in the DTC P1129. After completing the installation, it is advisable to recheck all connections and components involved to ensure optimal performance. This attention to detail is crucial for maintaining integrity throughout the vehicle's operation. In this Step 9 of troubleshooting, the technician should turn the ignition switch to the on position, denoted as position 2. Ensuring that all systems are active, this position allows for preparation of the ECM reset process. Resetting the ECM, engine control module, is an important procedure to clear any stored data related to fault conditions that might be present prior to the repair. It is advisable to use the HDS for this procedure, ensuring that the reset is executed correctly and effectively. This reset allows the system to relearn the new pressure readings from the recently installed map sensor after it has been replaced. Such a procedure is vital in restoring the accuracy and functionality of the vehicle's engine management system. Attention must be given to follow exact protocols to avoid any potential complications afterward. For Step 10, the idle learn procedure is necessary following the ECM reset. This procedure ensures that the engine control module relearns the proper idle conditions under the new setups after the map sensor replacement. To execute this, start the engine and allow it to reach a warm idle status without loading conditions. This is essential for accurately establishing how the engine should function under normal conditions. Proper execution of this procedure is critical as it influences future driving performance, fuel efficiency, and overall engine functionality. Failing to conduct the idle learn process may result in suboptimal performance and trigger further fault codes. Therefore, adherence to this step is vital for restoring peak operation. After all troubleshooting steps have been followed diligently, the final repair verification for DTC P1129 must be conducted. A test drive should be performed to see if the symptoms previously noted are resolved, assessing the functionality of the vehicle completely. During this drive, it is wise to observe if the engine responds well without triggering the DTC again, as this indicates successful repair. After completing the drive, using the Honda Diagnostic System to scan for any reoccurring DTCs is critical. If the DTC no longer appears, it suggests that the repair has resolved the initial issue. Hence, comprehensive verification of the repair is not just good practice, but essential for customer assurance and vehicle reliability. Preventive maintenance is an essential part of vehicle ownership to avoid future occurrences of DTC P1129. Regular checks of the MAP sensor can ensure that it remains in optimal working condition. Ideally, this should be performed during routine inspections or engine tune-ups. In addition, the vacuum lines associated with the intake manifold should be checked for leaks or wear and tear at regular intervals. Since vacuum leaks can lead to sensor inaccuracies, a proactive strategy will significantly enhance the performance and longevity of the vehicle. Staying ahead of potential issues prevents costly repairs in the long run, affirming the importance of maintenance in automotive care. In conclusion, understanding DTC P1129 is vital for Honda Accord owners from 2008 to 2012. The key lies in recognizing the importance of the MAP sensor and its role in engine performance. By following structured troubleshooting steps, technicians can effectively diagnose and resolve issues leading to this trouble code. Also, implementing preventive maintenance helps to avert similar occurrences in the future. Regular checks on the MAP sensor and vacuum lines are crucial for ensuring the vehicle runs smoothly. Through these comprehensive approaches, vehicle reliability and performance can be significantly enhanced. The accumulated knowledge serves not only to address immediate problems, but build a foundation for long-term vehicular care. Please like and subscribe to the channel. See you next time.